Okay, so today we're going to look at another method to solve a quadratic equation. It is called completing the square, and this can be useful for us not only to solve this quadratic equation, but also to change from standard form to vertex form, which we'll practice next class. So, number one, and this is completing the square. Problem number one. X squared plus 6x minus 30 equals negative 3. So what we're really concerned about when we complete the square is the terms that have the x's in them, that have the variables. And I've seen people leave this minus 30 here, and I've seen them put it to the other side. I would just as soon get rid of it. So I'm going to rearrange this equation just a little and make it x squared plus 6x, and over here I'll put, if I add 30 here, that makes it go away, and if I add 30 here, I guess I have 27. In completing the square, what we do is we force this problem right here to become factorable by adding on a number. When we add on a number here, just like we did when we added 30 to both sides, we'll have to add on that number here. And the question is just really, what do we add in? Well, the way you find that out is you look at this term, the linear term right here that has the 6 in it. So if I look at the linear term right there, then that value, the b value, if this is ax squared plus bx plus c, the b value is 6. And b over 2 then is 6 divided by 2, that is 3. And b over 2 squared would be 3 squared, that's 9. That is the magic number. So that's the number that I'm going to put right up here that will make this factorable. I write plus 9 here. If I add 9 to this side, I have to add 9 to this side. Now it is important to know that the a value has to be 1 in order to work completing the square problems. So the number before the x squared has to be a 1. This part right here, this trinomial, is now factorable. It'll become x plus 3 squared. Because it is really true that x plus 3 times x plus 3 equals x squared plus 6x plus 9 if I FOIL this out. So all I've done is factor this into what it equals. Equals 27 plus 9, I guess that's 36. The reason that it's nice to get this whole thing squared is because we can solve that now by taking the square root of each side. So if I take the square root of the left side and I take the square root of the right side, when I take the square root of 36, I have to consider the plus and the minus, because 6 times 6 is 36, but also negative 6 times negative 6 is 36. So there will be two different answers here. Now the opposite, or the undoer, the inverse of squaring is square rooting. They undo each other. And we get x plus 3 equals plus or minus 6. If I subtract 3 from both sides, I get x equals plus or minus 6 minus 3. Subtracted 3 from this side, subtract 3 from this side. That means I have two different answers. Number 1, positive 6 minus 3, and number 2, the negative 6 minus 3. 6 minus 3 is 3. Negative 6 minus 3 is a negative 9. Now we could have solved this problem using the quadratic formula, or we could have tried factoring it, and it would have given us the same answer. But we're working on a process here called completing the square, and it works the same way. problem number 2. X squared minus 12x plus 37 equals 2. And we follow the exact same process. I'm going to put the 37 to the other side to get rid of it. That gives me x squared minus 12x, and I'll leave a blank there for what I'm going to add on, equals, let's see here now. Hey, how are you? Can you give me 5 minutes? I'm making a recording right now. So just 5 minutes. Okay. So if I add something here, I'll have to add it to the other side also. But I got rid of this 37. Subtracted 37 from this side. That meant I had to subtract 37 from this side. 2 take away 37, that's a negative 35. And I have my places there ready to go for when I figure out what magic number I will add. The b value, the number before the x, is negative 12. So b equals negative 12. Then I take half of that, b over 2, which gives me negative 6. And then I take b over 2 squared. It's always half the middle term squared. Negative 6 squared gives me 36. That's what I'll add on. If I add it to one side, to keep it equal, I have to add it to the other side. Just like before, this part is factorable. It's called completing the square, and it will always come out to be a square. This will be x minus 6 squared when I factor it. It is true that x minus 6 times x minus 6 would give me x squared minus 12x plus 36. It's also true that this number right here, the negative 6, is the b over 2. Always, it's what goes in there. Over here, the b over 2 was 3. Always, that's the number that goes in there. Now, I've used up these 3 terms because these 3 together became this. On the other side, negative 35 plus 36, that's 1. Same process as last time. I'm going to square root this side. I'm going to square root this side considering the plus and the minus, because 1 times 1 is 1, and negative 1 times 1 is also 1. So I get x minus 6 equals plus or minus 1. And when I add 6 to both sides, I get x equals 6 plus or minus 1. I could have written the plus 6 on the end. That means I have 6 plus 1 and 6 minus 1. That gives me 7 and 5. 2 answers. Third example. X squared plus 4x minus 79 equals a negative 5. And again, what I want to do is get everything away from this. So x squared plus 4x. I'll have to add 79 to get rid of it, which means I have to add 79 over here. And when I add 79 to a negative 5, that gives me 74. Put my blanks in. The b value is 4. So b over 2 is 4 divided by 2, 2. And b divided by 2 squared is 4. 2 squared is 4. That is the magic number that I add on to each side. This part becomes factorable. It is x, let's see, either I know how to factor it, or I could always just use this, plus 2 squared. But x plus 2 times x plus 2 really does give me this. So that equals 78. Square root both sides. It doesn't look like this one's going to come out to be very nice, because the square root of 78 is not a perfect square. Consider the plus and minus, which means now I have x plus 2 equals plus or minus the square root of 78. When I subtract 2 from each side, I get minus 2 from here, makes it go away. When I subtract 2 from here, I could write it on the end, but I sort of prefer to write it in the beginning. Negative 2 plus or minus the square root of 78. So now I have to consider, does 78 break down? Because if it does, I need to do that. So 78 divided by 2 gives me 39. And 39 is 3 times 13, but I don't have any pairs there. So I won't be able to break this down. These are the two answers. They are irrational. Two more examples. Example number 4. X squared plus 16x plus 59 equals a negative 9. And ideally at this point I would like for you to pause the video and see if you can solve this before I do. So if you'll pause the video right now, try to solve this, and then we'll see how it goes. I will show you how to do it again. Okay, so x squared plus 16x, I get rid of that, which means I subtract 59 equals, when I subtract 59 from 9, I get minus 68. I'll need to leave a space. And the thing that I'll add on is, let's see, b is 16, b over 2 is 8, b over 2 squared is 8 squared is 64 is what I'll add on to both sides. This factors and becomes x plus 8 squared equals a negative 4. I can see that when I take the square root of both sides to solve this, the plus and the minus, I'm going to get an imaginary number there. So I get x plus 8 equals plus or minus the square root of negative 4. If I subtract 8 from both sides, I get x equals a negative 8 plus or minus the square root of negative 4. But I can still reduce this because I know what the square root of 4 is. It's 2, so it can come out. So I get x equals a negative 8 plus or minus. The 2 comes out, but that negative there has to stay in there. Square root of negative 1. The square root of negative 1 is known as I, an imaginary number. So we write it like this. X equals a negative 8 plus or minus 2I. So we'll begin this process now, and I think this is the first time we've seen it. Whenever you have a square root of a negative number, from here on out, we make the square root of the negative I for imaginary. In this case, we had the square root of 4, which we were able to bring out and make 2. So this is the answer. It is an imaginary number here, 2I, that's attached to this. Last example. X squared plus 5x minus 55 equals a negative 5. Pause the video, see if you can solve it before me. So we get x squared plus 5x. I'm going to push that 55 to the other side. Add 55, add 55, that gives me 50. I leave a blank here, I leave a blank here. B is 5, we're going to get into fractions. B over 2 then is 5 halves. B over 2 squared is 5 squared, which is 25, over 2 squared, which is 4. Nasty as it is, that is the magic number that we'll need to add on to both sides. This becomes factorable. It becomes x plus, no, I would never think this was factorable in a million years if I had not forced it to be. But since I completed the square, I know this is the number that always goes in there. 5 halves squared equals, here I have 50 plus 25 over 4. Well, 50, I'm going to rewrite that as, that's 200 over 4, plus 25 over 4. So we get x plus 5 halves squared equals 225 over 4. Square root the left, square root the right, plus and minus. It is the same process even though we have harder numbers. And we get x plus 5 halves equals plus or minus the square root of 225 over 4. Well, the square root of 225, let's see, I believe that's 15. Yes, it is. And the square root of 4 is 2. So it's cleaning up a little bit. I still want to get rid of this, so I subtract 5 halves from this side. Subtract 5 halves from this side, and I get x equals a negative 5 halves plus or minus 15 over 2. Which means I get x equals a negative 5 plus 15 over 2, and x equals a negative 5 minus 15 over 2. Negative 5 plus 15 is 10, divided by 2, x is 5. Negative 5 minus 15 is a negative 20, divided by 2, x equals a negative 10. This is the process of completing the square. This was your homework assignment. Bring these clearly written notes with you next class, and I will give you credit for it.